Lesson 5.6, Solving Exponential and Log Functions. Let's take a look at example 1, solving logarithmic functions first. As we take a look at letter A, we've got log base 3 of 4 equals 2 log base 3 of x. I know that that 2 can be brought up, so log base 3 of 4 equals log base 3 of x squared. Well, if they're both log base 3's, then that must mean that the number contained inside must be equivalent, since these are equal. So 4 is equal to x squared. Well, if I want to solve for x, I square root both sides. Remember, when you square root both sides, you absolutely must need plus minus. So in this case, x is equal to 2 and negative 2. Does that make sense? Well, can we have log base 3 of 2? Sure, we can have that. Can we have log base 3 of negative 2? Because that would be there, right? Oh, well, one thing about logs is the graph, if you remember, we have an asymptote here. All of our x values always need to be positive, so this negative 2 is not going to work. We only have the answer of x equals 2. Let's take a look at example 2. Letter A, ln of x minus 1 plus ln of x equals ln of x plus 2. Using properties of logs, if I have an addition sign there, I can combine this as one log. So ln of all x minus 1 times x equals ln of x plus 2. Again, I have natural log equals natural log. So because of this, that must mean that the numbers contained within them are equivalent. So what we're saying now is, multiplying this out as well, we get x squared minus x is equivalent to x plus 2. This looks like a quadratic that we will have to solve. So moving our terms over to one side, subtract x, x squared minus 2x, subtract 2, equals 0. Remember, we need the zero product property, so that way we can actually factor. If we can factor. This is actually not factorable. So what do we have to rely on? We need our quadratic formula. So x equals negative b, so negative negative 2, plus or minus the square root of b squared minus 4ac all over 2a. 2. All right. We have 8, 12, so we have square root of 12. So this is going to give us x equals 2 plus or minus the square root of 12, which is 2 root 3, all over 2. Oh, notice how they all have 2's in common. So this is the same thing as 1 plus or minus the square root of 3. Wait a minute, let's double check some of these values. All right, so 1 plus or minus root 3. Remember that because this is my x value, I do need to make sure that it will work within a natural log. I guess the easiest thing to check is the middle term, because we see natural log of x. I know that x itself must be a value greater than 0. If x is not greater than 0, then this is not going to work. I need a positive number in there. Okay, so let's go ahead and give it a try. Hopefully you're starting to see what root 3 is, but let's just show you 1 plus square root of 3. Well, that's definitely going to be positive, right? That's 2.73. But what if I wanted 1 minus? Uh-oh, that's a negative value. So we don't want the negative sign. When instead, we should only have the answer of 1 plus root 3, like that. Okay. All right, let's go on. Example 3. Now we're going to solve exponential functions instead of log functions. So let's take a look at which one we should solve. I guess let's just start with A. That's the first one, right? So 9 to the x minus 3 to the x minus 6. Those aren't really common terms that we can solve for. Instead, if it does kind of look familiar, hopefully what you're saying to yourself is that a quadratic? Can we make that a quadratic? That's what you want to try to do. Okay? So in this case, if you think about what our base value is exponential, we have a base of 3. So 9 is really 3 squared to the power of x minus 3 to the x minus 6 equals 0. Now this is really the same as, if you recall, this is just using your properties of exponents. This is really 3 to the 2x. Or another way of thinking about it is this is the same as 3 to the x squared, right? Because that 2 times x can, you can move your exponents around. 2 times x is really x times 2, and then you can use your properties of exponents there. So this is the same thing as 3 to the x squared minus 3 to the x. Notice how I am putting in parentheses for a good reason, because it is kind of looking like a quadratic. What if I made my 3 to the x into something else? Let's say like an a. Then what we have is a squared minus a minus 6 equals 0. And voila, we have a quadratic. That is factorable, right? What we get is a minus 3 times a plus 2 equals 0. So therefore, based on zero product property, a is equal to 3, and also a is equal to negative 2. Don't stop there. Don't box your answer yet. Are we solving for a? No, we're solving for x. What is a? A is 3 to the x. So let's plug that 3 to the x back in. What we're saying then is 3 to the x is equal to 3, and also 3 to the x is equal to negative 2 from our second one as well. Okay, so don't forget the second one. So 3 to the x equals 3. Well, that just means that there must be an exponent of 1. So, oh, x is just 1 then. That's a nice easy one to solve. The second one's a little bit trickier. 3 to the x equals negative 2. When does that happen? Hopefully what you're seeing, visualizing, is that 3 to the power of x, that's an exponential. And we know that exponentials look like this, right? We know that it has a point at 0, 1, right? If we plug in 1, we know we're going to be at 1, 3. Okay, so these are the order pairs we definitely know. But what you also see on the graph is that, remember, exponentials always have asymptotes here, meaning exponentials can never really go below the x-axis, at least for the parent function. Right? So if it can't go below the x-axis, that must mean that exponentials are always, always positive. And if they're always positive, there's no way that this can be a negative 2. So this is not going to give us anything at all. We can't get an answer there. So we only get one answer, x equals 1. Okay. Let's take a look at another one. Let's do letter E. This is kind of like in the same vein. We see that we do have a quadratic, actually, because it is very similar. Why don't we skip that one and let's do f instead. Okay, so e to the x, we've seen something like this before, minus, negative exponents means we should actually do its reciprocal, e to the x like that on the bottom, equals 1. Now, I want that to look like a quadratic. It's not quite a quadratic just yet, but the e to the x on the denominator is definitely in the way. So what can we do? Why don't we multiply everything by e to the x? In that way, we're going to get e to the x basically squared minus e to the x over e to the x cancel, so we have 6 equals e to the x. Okay, and now it's kind of looking like a quadratic, where if I bring that e to the x over to the other side, like that, and then we say, let's make a equal e to the x, so we have a squared minus a minus 6 equals 0. Wait a minute, this is sounding very familiar. Didn't we just do that? We did. So this is the same thing as a minus 3 times a plus 2 equals 0. You know what? I'll let you handle the rest of this. I do want to take a look at e though. Let's say that we have 3 to the 2x. This is really the same thing as 3 to the x squared minus 5 times 3 to the x plus 4 equals 0. Again, notice how a quadratic can be formed if you simplify it and make 3 to the x equal to a. So a squared minus 5a plus 4 equals 0, like that. Okay. From there, if you factor this, we see that we're going to get a minus 1, a minus 4 equals 0. So a is 1 and a is 4. Don't forget, you're not solving for a, you're really solving for x. So 3 to the x equals 1 and 3 to the x equals 4. When does an exponent ever equal 1? Oh, when it's a degree of 0, or when it's an exponent of 0. Anything to the 0 power, right? All right, 3 to the x equals 4, that's a little bit trickier. Well, if you think about how if you want to solve for x, you can log both sides to do the inverse of exponential. Then what we have is x log 3 equals log 4. And then divide both sides, log 4 over log 3. And then remember, you also have a change of base. So this is the same thing as log base 3 of 4, like that. Okay. If you do want to enter that into your calculator, let's go ahead and do that. Just to get the decimal equivalent. You might encounter that on MyMathLab. So what we want to do, I'm going to do this split screen actually. What we want to do is find log base 3 of 4, or we saw that's log 4 over log 3. Same idea. Okay, my calculator cannot do log base 3 of 4, so I'm just going to do my change of base formula instead. So we have, let's see here, log 4 divided by log 3. And that'll give us an equivalent value of 1.26 then. Okay, 1.262 to be more exact. 1.262. Okay, all right. That'll do it for today.